There we go. Okay, so today, continuing with our theme of right triangles, we're going to talk about trig ratios, sine, cosine, and tangent with right triangles. So this is going to be pretty new to everybody, I think, and it's going to be something that you're going to use pretty much throughout the rest of the math classes that you'll take. And a lot of really convenient things happen with angle relationships in right triangles and angle side relationships. And so someone noticed this and created these trigonometric ratios that we will be talking about today. So go ahead and grab whatever it is you're using to take notes, and let's get started. And let's see, here we go. Okay. So this is technically in the book a combination of like 9.4 and 9.5. Because the way that they break it down in the textbook is a little bit different. They do like they talk to you about two of the trigonometric ratios and in one section, and they talk to you about another one in another section. And then they talk about word problems and stuff in another section, and like solving a whole triangle in another. And it's just kind of weirdly broken up. And so I kind of combine the sections and then just spend a longer time talking about them overall. So 9.4 and 9.5, we're going to be talking about sine, cosine, and tangent. And it looks like sin, cos, tan. And that's what it looks like in your calculator too. But anyway, the first thing we got to talk about is, what do these things mean? Okay. So we know they have to do with right triangles. So over off to the side, I'm going to draw a right triangle to kind of help us out here. With corners, vertices labeled A, B, and C. And so just remembering from yesterday a few things about right triangles. Who remembers what were the shorter two sides called? What did we call those? The legs. So yeah, remembering that these were the legs. And then what was this side called? Yeah, the hypotenuse, exactly. Because it's across from that right angle. And so yesterday, just to recap real quick, we talked about the Pythagorean theorem, which was leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared, depending on how you like to think about it. And so sine, cosine, and tangent have to do with the relationship between the side lengths on a right triangle and the angles on a right triangle. And so starting with sine. The abbreviation for sine is actually that S-I-N. It's actually, if you were to spell the whole word out, it's S-I-N-E, sine, which is why it's read as sine instead of sin. A lot of people get that mixed up. And so the sine ratio, or the sine of an angle, is the opposite side to an angle, that side length, divided by the hypotenuse. Okay. And so we're going to write down what these ratios are, what they mean, and then we're going to go through a more practical example of how we can find these things. So bear with me here. So sine is the opposite side length divided by the hypotenuse. cosine, which also is abbreviated as COS. That's why a lot of people go, oh, cos. But it's, if you were to spell the whole thing out, it's really spelled as cosine. Cosine is the adjacent side divided by the length of the hypotenuse. And then the last one, tangent, it's abbreviated as tan, but if you were to spell it out, it would be tangent. And tangent is the opposite side divided by the length of the adjacent side. So those are what the three ratios are. And there's a couple of different ways you can find the ratios. And there's different ways that we talk about the sine, the cosine, and the tangent with respect to either a triangle or with respect to just an angle. So our first example of how we would deal with these is if we are given the sides of a triangle. So for example, if I'm given a triangle that looks like this, and I know all three side lengths just like that, we could be asked for something with respect to angle A. We could be asked for sine, cosine, and tangent with respect to angle A. We could also be asked for sine, cosine, and tangent with respect to angle B. Okay, so the way that we would be asked for these things is we would be asked, what is the sine of angle A? Like that. So typically when you see sine, cosine, or tangent, you'll see something in parentheses, and that something in parentheses will be an angle. Okay, so the sine of angle A is going to be the length of the opposite side to angle A divided by the length of the hypotenuse. So looking at this picture, the side that's opposite of angle A is going to be the one that's across from it, that's not touching angle A. So that would be the number 3, this side length here. This is the opposite to angle A. And then the hypotenuse is the same either way. The hypotenuse is always across from that right angle. So the hypotenuse would be 5. So if sine is the opposite divided by the hypotenuse, this sine of A would be 3 over 5. So if you were asked what is the sine of angle A, you would put 3 over 5. That would be your answer. We could also be asked for the cosine of angle A. Now for angle A, we've already identified the opposite and the hypotenuse. The remaining side is the adjacent one. Adjacent means that it's touching that angle, but it's not the hypotenuse. And a lot of times we abbreviate it as just like ADJ, kind of like we abbreviate opposite OPP. And a lot of times you'll abbreviate the hypotenuse HYP. It's a little bit easier if you abbreviate. Or at least I think so. And so cosine, we look up here and we know cosine is adjacent over hypotenuse. So for cosine of A, we would get 4 over 5. All right. And then lastly, we could be asked for the tangent of angle A. And tangent is opposite over adjacent. So opposite over adjacent to angle A would be 3/4. Okay. So that's the sine, the cosine, and the tangent for angle A. Now, if we were to switch our perspective and do things for angle B, then we would have to relabel our sides as opposite, adjacent, and hypotenuse with respect to angle B instead. So that's what we're going to look at next. Next, we're going to want the sine of B, the cosine of B, and the tangent of B. So this time, if we're looking with respect to angle B, what's the opposite side going to be for angle B? It'll be 3, 4, or 5 for opposite of angle B. 4. Yeah, exactly. So 4 is the one that is across from, not touching angle B. Thanks, everybody. So this would be the opposite for angle B. So this is where I like to use different colors. If you want to just like, if you don't have different colors and you want to put like in parentheses B next to it or something like that so that you remember which one it's opposite for, you can. And then the hypotenuse is still the hypotenuse, no matter which perspective we're looking at it from. The hypotenuse is always the same. So really it's just the opposite and the adjacent that switch, because 3 is the adjacent side for angle B. So now we go through and do these same ratios again, except using the sides labeled with respect to angle B. So for opposite over hypotenuse, for sine, we'd go 4/5. For cosine, adjacent over hypotenuse, we would go 3/5. And then for tangent, opposite over adjacent, we would go 4/3. So what do we notice about sine and cosine with angle A and angle B? What's the difference? Anyone see it? Okay, sure, it went down a number. Also, if you take a look at cosine of A and sine of B, the turntables have turned. Yes. Oh, man. Excellent location for an office reference. Yes, my, how the turntables. Cosine of A and sine of B are the same. Sine of A and cosine of B are the same. They've just switched places with one another because the opposite and the adjacent have switched with one another. Same thing with tangent. Tangent of A is 3/4, tangent of B is 4/3. They're just switching places. So it really depends on the perspective, from which angle's perspective you're looking at, as to which, or what makes up your trig ratios. Okay. So any questions at this point? Any numbers we're not sure where they came from? Any steps we're not sure how they happen? Okay. Now you might look at this and go, well, this is nice, but why the heck are we doing this? And that's going to become a little bit more clear as we go through the next couple of days. This is just kind of baby stepping our way into sine, cosine, and tangent, but these are actually things that we're going to be able to use to find missing sides and missing angles on a triangle, and things like that. So it'll become very clear why we're doing this as the week goes on. One thing I do want to mention, a lot of people at first, when we're first learning how to do sine, cosine, and tangent, have a hard time remembering the ratios. and remembering, wait, is sine opposite or adjacent, or what is sine? So an easy kind of mnemonic that people came up with to help remember, or an easy acronym, I guess, is notice how sine is opposite over hypotenuse, right? So they took the first 3 letters there and went, so that's how I'm going to remember sine is opposite over hypotenuse. And then cosine is adjacent over hypotenuse. So they went, okay, CAH. Cosine is adjacent over hypotenuse. That's how I'm going to remember cosine. And then tangent is opposite over adjacent. TOA. Tangent is opposite over adjacent. That's how I'm going to remember tangent. So saying all 3 together, you get so ka toa, which is what a lot of people like to use to help them remember what sine, cosine, and tangent stand for. So if it helps you to remember so ka toa, feel free to use it. That's what I used when I was a student, first learning it. We remembered it with so ka toa. Okay. So this is one particular instance or one particular setup or problem that you guys will see, given the 3 sides of a triangle. We're going to do one where we're given just 2 sides, and that'll require like a little extra step before we can do the trig ratios. So second example. Given another right triangle here. We'll call it triangle PQR. And we know that this side length here is 5. This one is 12. And we are going to be asked for sine of P, cosine of P, tangent of P, and then sine of Q, cosine of Q, and tangent of Q. Okay. So looking at this one, we've got 2 of the sides, but in order to do all 3 trig ratios, we're going to need the third side. And yesterday, we learned that we could find the third side of a right triangle using the Pythagorean theorem. So we have to do that first step. And then it will become just like the first example. So this would be my C value over here, because that's the hypotenuse. And then 5 and 12 can be A and B. So doing that first step here, A squared plus B squared equals C squared. Gives me 5 squared plus 12 squared equals C squared. 5 squared is 25. 12 squared is 144. Adding these together, we get 169. And that's equal to C squared, so we have to square root both sides. And it turns out that 13 is my missing side length C. So now that I know that, now we're in business. We can do the sine, cosine, and tangent for angles P and Q. Okay. So starting with angle P. I'm going to actually have, now that we've got this missing side here, I'm going to have you guys try this real quick. So label the sides as opposite, adjacent, and hypotenuse to angle P, and then find the sine, cosine, and tangent for angle P. When you're done with angle P, type done in the chat. And feel free to use what we did up here as kind of something to go off of. All right, Jade's already done. Nice. Caleb's done. That was quick. Adon's done. You guys are fast. All right, Lauren, Ashton, Alex, awesome. Nice job, Kaylee. Okay. Give you guys 30 more seconds. All right, for those of you who are done, sine of P, what'd we get? 12/13. Awesome. Yes, because 12 is the opposite side to angle P. 13 is the hypotenuse. So 12/13. How about cosine of P? Anyone get that one? 5/13. Yep. Because 5 is the adjacent side to angle P. And then lastly, tangent of P, what do we get? 12/5. Awesome. All right. Yeah, because opposite over adjacent, 12/5. Alrighty, so same thing, but for Q this time. Go ahead and do it. And when you've got it, type Q in the chat. Some of you already got it. You're ahead of us here. Nice. All right, Caleb's got it as well. Nice job, Caleb and Jade. Adon, good work. Nolan, awesome. All right, 10 more seconds. All right, nice job, everybody. This time, going off of angle Q, what's our sine of Q going to be? 5/13. One way you could do it is figuring out that the opposite of Q is 5, and the hypotenuse is still 13. The other way you could do it is you could notice that pattern that we saw up here, where cosine of one is the sine of the other, and gone, okay, if cosine of P is 5/13, that'll be sine of Q. Either way you want to do that is fine. What would cosine of Q be? Yep, 12/13. Nice, because that's adjacent over hypotenuse. And then tangent of Q. Yep, 5/12. And again, you could have gone, okay, opposite over adjacent with respect to Q, or you could have flipped the tangent that we had for P. Either way. Awesome. So that's one kind of problem that you guys are going to be expected to do today. The other kind of problem you're going to be asked to do today is actually super simple, because it involves just typing things into a calculator, but we want to make sure that we get familiar with typing these particular things into the calculator. So if you have a scientific calculator nearby, go ahead and grab it. If you're in the habit of using a cell phone calculator, those are not the most amazing for trig functions unless you download an app. If you want to download like the Desmos calculator app, that will work on your phone pretty well. But using just a standard iPhone calculator gets a little bit confusing when you're doing sine, cosine, and tangent because of the order that you have to type things being a little bit weird. It's doable, it's just very prone to making mistakes. So if you want to avoid mistakes, I recommend either using a regular calculator the Desmos app or Desmos on your Chromebook or something like that. Also, Desmos is what's used in state standardized testing, so that's a good thing to get familiar with. But anyways, so the other thing we're going to do is look at sine, cosine, and tangent in the calculator. And I'll show both. I'll show a scientific calculator. I'll show the Desmos calculator as well. Okay, so sine, cosine, tangent in a calculator. So when you're doing sine, cosine, and tangent in a calculator, you'll typically be given an angle and asked to find the sine, cosine, or tangent of that angle. So I could be asked for the sine of 35 or the cosine of 47 or the tangent of 67 or something like that. So let's see, can we see this? Not super well. I'm going to grab my graphing calculator because it has a light on it, or because it has a backlit screen. If you guys can see this, you'll see that there's these 3 buttons here, sine, cosine, tangent. We're going to start using those today. So if you wanted to type sine, you can hit sine and then go 35, enter. And it will tell you the exact decimal of the sine ratio when your angle is 35 degrees. If you have a hard time seeing that, no worries. This one is a little bit better lighting wise. And it still has that sine, cosine, tangent button. If you hit sine and then you type 35 and hit enter, it gives you that really long decimal. And so depending on what you're asked to round to, typically if you're going to round it to use it in a problem, you want to go to like 4 decimal places or something like that. Something so that you don't end up having a rounding error later on in the problem. Because these things that we're doing here, finding sine, cosine, and tangent of angles, is going to be something that we use later on this week to help solve for other missing things. And we want to be as accurate as possible. So personally, I like to go to like 3 or 4 decimal places. So sine of 35, for example, we would go 0.5736 because the 7 tells me to round the 5 up to a 6. Okay. And we can do that with cosine and with tangent in a calculator as well. For those of you who are working with Desmos, I'm going to show that next because Desmos is a little bit different. So the first thing that you want to do when you get to Desmos, if you're going to use Desmos to do trig, is you're going to want to click on the wrench. Because Desmos naturally comes in this mode called radian mode, which is great if you're doing like advanced algebra trig or pre-calculus. You'll start learning about radians. But since we're in geometry, we're going to talk degrees. And a lot of the problems that you'll see in life will be dealing in degrees, not in radians. So you click on the wrench, and then you click on degrees and make sure that that's the one that's highlighted in green before you do anything, because otherwise you're going to get weird answers. So make sure we're in degrees mode. And actually your regular calculators also have degree mode and radian mode, which I'll talk about in a moment. But we're more prone to that issue in Desmos. So then you'd click in the box up here, and you want the keyboard. You can type sine on your own keyboard, like type SIN, parentheses 35, and it will do sine of 35 for you. You can also find it under functions. So if you click on functions, and under trig, you'll notice there's sine, cosine, and tangent. So you can type sine 35, and it gives you sine of 35. So whichever way you would like to do that is totally fine. That's how we would find sine of 35. Also, if you're on like a scientific calculator and you're not sure if you got an answer that was not this when you typed it in, you might also be in the wrong mode. So you would want to click on the mode button and make sure that degree, DEG, is the one that's highlighted, and click enter. And then you can hit second quit, or second mode, which gets you out of that program. Same thing if you have a graphing calculator already, you can hit mode and make sure that the degree mode is highlighted. It works the same way. We want to make sure that we're in degree mode for now. Okay, so the next thing that we would do is you can do it for cosine as well. You can find cosine of 47, enter. And we would get 0.68. The 9 rounds the 9 up, which rounds the 1 up to a 2. And then the same thing, we can do tangent 67, enter. And that gives us 2.3559 if I'm going to 4 decimal places. Okay, so I'm going to have you guys try real quick. Using whichever calculator method you would like. You can use a scientific calculator. You can use an online calculator. I would like you guys to find the sine of 42, the cosine of 107, and the tangent of 78 to 4 decimal places. So go ahead and do those real quick. When you think you've got them, type "got it" in the chat. All right, Adon's got it. Caleb's got it. Awesome. Almost done for the day, guys. This is our last thing. All right, 15 more seconds. Awesome. Okay. So for sine of 42, we should have gotten 6691. If you got something else, you might have typed something wrong, or your calculator might be in the wrong mode. So make sure we troubleshoot that. cosine of 107 should be negative 0.2924. And then tangent of 78 would be 4.7046. Okay. So there we go. Sine, cosine, and tangent. So typically we think of these in the context of right triangles, right? And so cosine of 107 is not something that you'll typically be taking because a 107-degree angle will not be part of a right triangle. But as you get further along in math, you'll notice that we do take sine, cosine, and tangent of larger angles when we're not relating it back specifically to right triangles with all positive side lengths and whatnot. So anyway, that'll be something that we work with later. Not in this class, though. So that is why that one was negative as opposed to positive. All right, so before we get the homework real quick, I want to do a poll. And on this poll, so if you go to the chat section and then click on the three little shapes, you'll see a poll. You have to click on polls, though. And I want to know, for a calculator, what primarily do you use? Do you have a scientific calculator at home that's like separate from your cell phone or your computer? Do you have a graphing calculator? Do you use Desmos, either the app or the website? Do you typically use your phone calculator, or do you use something else? So go ahead, answer in the poll section real quick. What do you prefer to use? And I would like everybody to vote, please. I've got about 6 people who have voted so far. And if you're not sure what your calculator is, if you have a calculator at home that has sine, cosine, and tangent buttons on it, it's at least a scientific calculator. All right. 15 more seconds. Okay. For those of you who are dead set on using your cell phone as a calculator, that's fine, but I highly recommend that you download a calculator app of some kind if you have room for it on your phone. So if you go to like the App Store, whichever app store you use, and you type in Desmos. This is a good graphing calculator for a phone. It also does like regular scientific calculator functions. It's just like the website, and it's free, I believe. So I would recommend downloading this or whatever other calculator on here that you're comfortable with that actually types out sine, cosine, and tangent and stuff like that, because as wonderful as the calculator that your phone comes with is, it's not super amazing when it comes to using sine, cosine, and tangent. So that's my recommendation if you are planning to use your cell phone as a calculator. I would also recommend just getting some kind of a scientific calculator because they're good to have for things like when you go to take the SAT in the future. You'll want to have a calculator of some sort that you can bring with you because they will not allow you to use a cell phone for a calculator on the SAT. So for those of you who are thinking towards the future, I would recommend picking up a calculator of some kind that does not have internet capabilities. Anyway, done with that. Let's go ahead and take a look at our homework assignment for today. So today's homework is 2 IXL sections. We have trigonometric ratios, sine, cosine, and tangent is algebra HH1. So this is what it looks like. They'll give you a triangle. Sometimes it will have all 3 sides already. Sometimes it will not. And it'll ask you, like, what is the sine of G? And so you'll answer as an integer or as a decimal for this one. So, for example, on this one, sine of G, the opposite over hypotenuse would be 12 over 13. Not sure if it'll allow you to answer as a fraction on this one. I don't think it will. So a decimal rounded to the nearest hundredth, if you'd go 12 divided by 13 in your calculator, would be 0.92. Okay, so we're rounding to the nearest hundredth. The reason I did this one instead of the geometry one was that the geometry one required a lot of rationalizing the denominator and didn't really isolate the skill that I wanted us to get. And so anyway, that's why we're doing it in the algebra version of things. Then find the trigonometric functions using a calculator. Write your answer as an integer or decimal rounded to the nearest hundredth. So this is just like what we were doing before. You type sine 74 into the calculator, and we're rounding to 2 decimal places since it's the nearest hundredth here. So this one would be 0.96. Okay, so both of these should go fairly quickly, especially once you get the hang of it. Those are going to be our assignment for today. I will also post an exit ticket in a moment. Any questions, comments, or concerns before we start talking HSBP stuff?